Good evening, everyone. We are honored to have with us Dr. Catherine Kind, Chief Data Scientist and AI Director for Global Growth Markets at Cognizant Switzerland. With over 2 decades of expertise in artificial intelligence, data science, and quantum computing, Dr. Kind is a globally recognized leader and keynote speaker. She has been honored with titles such as Top Chief AI Scientist 2025, Voice of Ethical AI 2025, and Top AI Leader in Quantum Computing. Her insights will guide us through the critical intersections of AI, quantum computing, and digital security, areas that are shaping the future of innovation and trust. Ladies and gentlemen, please join me in warmly welcoming Dr. Catherine Kind.
Yeah, dear faculty, thank you very much for the invitation. I'll start, and I apologize beforehand that I have to leave after I finish the presentation. You're very welcome to send me all your questions. Please on the chat, I'll answer them on the next session. I unfortunately have a personal situation, so I'll just start right here. So the main area here is just to give you them a next level of understanding what quantum security is and why also this is the next evolution of artificial intelligence and how cybersecurity is now going to merge through quantum computing with what would be then AI. So when we could also call it the synergies between both. And there's still challenges, but these challenges create a lot of opportunities for research and new jobs, and also then to give you a first advantage on how you can prepare yourself for this future. So when moving on to understanding quantum security, I'm going to make what would be here the first assumption that there's the basics of cybersecurity and the mathematics behind them here are already known. Yes, so I'm not going to be going here into this much in depth. What I'm going to be moving here is on giving you what would be the fundamental concepts of quantum cryptography. So in the previous session was to give you first an introduction on the differences on how quantum computers work to classical computers. As I mentioned, the emulation works in that once the verification and validation has been done from what would be the physical computer, and there is then an emulation, so direct physical connection. And so there's cables to the HPCs, so the high power computer pairs, so actually 2 of them, that validate and are the direct access on the application layer to the physical logical qubits. So when we go here, we have 2 algorithms. Yeah, so the first one is then Chauver's mathematics, and then with Chauver, we are having the ability to come up with what would be a first factorizing and prediction. So the number one first to introduce you to this is to understand the phenomena, the basics on this. So there is, as I mentioned before, the need to understand quantum mechanics, and one of the area here is on the superposition. That means 2 photons, 2 pieces of light pairs, they get stimulated, and in this stimulation they have both states, zeros and ones, and they start to react like a network. Yeah, so that's why I put you the picture on the other side to give you what would be the best explanation on how entanglement works. Yeah? So once these photons have been stimulated and they're giving the particularly task, they have both states, and they later on, once let's say the stimulation stops, yeah, they collapse into one what would be of these states, either a 0 or a 1, which is what gets measured. So that allows us to use that factual measure, in order then to be able to resolve for the Schober's algorithm and be able, let's say, to profit from the performance of the quantum properties for data security. So one of this then basic understanding is that this allows us to have a different type of key distribution, which is what we call here the quantum key distribution. And these are a different set of protocols that allow for secure encryption and allows to detect what would be any kind of external malicious attacks, or eavesdroppers, by changing what would be here quantum states during what would be the transmission. So that means the transmission of communication between the quantum to what would be then a particularly net. It's not a net, but I don't have a better way to very let's say fast explain you how the entanglement of a task would work, because they work differently. So they are light photons at absolute 0, and they're working together at the hardware qubit layers. So what you see here would be let's say a showcase for one task repetition. So this would be an equivalent of 1 bit. So 1 bit, you have a 0 and a 1. And here you would have the equivalent of those states in the quantum state. So you can see all the nodes and all the points are all different tasks being executed simultaneously. And that is 1 qubit. So I hope that is understood. And it's a different let's say way of giving you an abstraction of this. So it's not, let's say, a 0 and a 1, which everyone can understand. You can see your laptops, let's say PCB LED glowing, you can hear the cracking as it's heard, and then you can see the zeros and the ones, so to say, through this LED. But in this case here, they're all stimulated at once, and all these tasks that are executed at once within 1 qubit. You cannot see it, just simply we measure the effect. So that means that this allows, so this is just one qubit form. So you can have let's say thousands and thousands of tasks, executions, done within just a 1 qubit form. So what is what we cannot do? So in the current classical computers, which is to also to understand, well, why to have then a quantum computer measures? Well, if we start to understand an encryption method, in classical encryption, we depend, for example, on standards on data security, ECC, RSS encryption. But this can be resolved using, for example, Schober's algorithm within a couple of seconds. That means that they're all obsolete and they're vulnerable to quantum attacks. That means that they can break this encryption, and it can solve and resolve for these problems efficiently within a couple of seconds. So that means that now, in order to go there, I would need to go into a separate lesson on the mathematics for that, but it's a lecture on its own. But the way that you can imagine this, think that you're trying to execute Word on a calculator from the 80s, versus your computer today. I just simply wouldn't be possible. So it is only, let's say, a single task, and it has a very small memory, and it can only, let's say, the multiplication, division, so basic, or if it's a scientific calculator, maybe with a plotter could do more. And if you would have, for example, MATLAB in your computer, you can just simply do m plus m analysis. So that would be the difference in the power, to give you let's say an analogy, about the differences in performance and power. So that means this vulnerability needs to be counter-used or counter-protected by using a quantum-resistant technique, which means that to protect any kind of breaches, and we need these new encryption methods, which are resilient. That means creating what is called a PQC, as a post-quantum crypt strategy. So what are some of the benefits that we can go here is we can have then unparalleled protection. That means that it definitely ensures the quantum future threats. It takes a good emulation. You need at least, like I mentioned, so in India, you can find quantum computers with 240 bits, but in order to, let's say, crack higher level codes, for example, like blockchain, you would need around 2000 qubits, which are not in a quantum computer than in India, but we have them in Europe, but they are still safe and sound in our research laboratories here in Switzerland or in Germany or in Denmark, where you can find them. And the main point is that to be able then to have the higher level, you need the bigger size. I already give you an example of a 2000 qubit quantum computer. And it's that the main challenge here is that of the hardware complexity, as I mentioned to you before. Yeah, the precise the precise cryogenic control, the stabilization management, and all these sophisticated components for the reliable operation, as well as there is a transmission distance limitation. Yeah, it can only be used within one and the same particularly geolocation. So of course you can have access to a simulation. Yeah, that means that the quantum computer gets connected to the TPCs, or to a TPU or so the QPU to a TPU, so a quantum computer to a classical high performance computer. And then this high performance computer simulation is what you can access over the cloud. Yeah, for example, from AWS, Google, Microsoft, as I mentioned before, or D-Wave from IBM. But if you really want to be able to, let's say, do higher levels of encryption and be able then to have what would be a result, you need to have the quantum emulation, so which is the direct cable, we call it the ANIC transmission, within the same location. Yeah, that means you would need a quantum computer in the same, let's say, block. And so in order to, let's say, crack what would be the encryption in a bank. Yeah? And that is right now not possible. Why? Because as I mentioned before, they're pretty big, and it's a good thing so at the moment. But there is still what would be evolutions. Yeah, so the day that they start becoming, let's say that this transmission distance limitation gets let's say it's no longer present, and Forrester created a survey this year showing, they're predicting in their benchmark assessment that in 5 years, by 2030, this particular challenge will be resolved, which gives us then, keeps banks actually quite a lot to worry from. And another area is here's on the integration challenges, integrating quantum security to the particular infrastructure, because it requires then the knowledge of the use of what would be the application level and also of the computer language level, which is still a significant challenge for a widespread adoption, which is actually right now, nowadays, still a pretty good thing. So let's move on into how this can help then, or how can artificial intelligence help through the evolution and the use of quantum computing in this aspect. Well, if we have then already established machine learning and AI that is already able then to, let's say, make the analysis of them, mathematics, and on the particular, what would be resolve for parameters in RSESS, it allows us also to create what would be then more advanced, based on machine learning and AI on quantum computing, counter new encryption methods. Yeah, so because this is, let's say, they're very complex mathematical, what would be then encryption mechanisms, we need the help of ML and AI to be able to create what would be the new aspects. But then, of course, the first theories, the first mathematical theories are or still are done by hand in this way, together then with physics. So, and what are one of the aspects that can help us? Well, yes, so first, of course, to mimic the human brain functions in order to improve, for example, image recognition and complex data analysis. And what would be, so one of the different ways in which you can encrypt things using quantum is that you have what would be motion-based type of an application. I want to give you an example. What is something that's very difficult to deepfake? I mean, of course, you can deepfake if you want to access some facility, a person in its normal, let's say, state. So when you take a picture of someone, for example, in your passport, your driver's license, but when you go and then you tell someone, well, you're only allowed to access, yeah, and you have to smile and you have to laugh. And in that case, the micro mimic and the different movements, yeah, on your face, the different muscles of your face create what it's called a unique pattern. Yeah, and this gets processed really fast. And then added to other, what would be biometric security from your eyes and your fingerprint would will create a 3-level prevention access. So this new type of image recognition, it's not just the 3D of your face in a state, but it would be that in that particular sense, you would not be able to have the same micromimic twice. So if I smile like this, is different than if I smile like that. So this creates a series of complex data analysis. So the new type level of encryption is using and forming all of this, just like a person. You have a good feeling about someone, yeah, because you see what they're saying, but also you see their micromimic, or you see also their body language, and both have to be coherent. And that's when you say, when they're incoherent, this is when we say in the human beings, my sixth sense telling me something's off, but it's actually your brain, your brain functions in which the image recognition of your brain are analyzing the particular voiceover of something versus the micromimicking, and it's not matching a particular logic way. So it's the same way in which a quantum computer algorithm in this case will be working. It's of course still uses reinforcement learning through trial error, and then the best way in order then to let's say bringing about an acceleration, we create this new type of encryption methods, not as a person. It's not just the cybersecurity expert. It's actually a group. And so you need the neurolinguistics, you need the particularly quantum physics mathematicians to be able to create what would be a new advance. It's created in collaboration. And then there is, for example, a way that you can create a new type of user interface. So what do you do when you're accessing a quantum computer in this case? Then it becomes a little bit, as in science fiction, I know, like Star Trek, like when you would see them, that they will just look at their penis and say, computer, beam me up. Yeah, so it would be the same type of interaction. Yeah, you would not be, let's say, working with it on a keyboard or having a mouse and a desktop. It's really mainly then through a human language. The computer itself, through already NLP, so speech to text, is able then to pick it up. But that allows for what would be a new type of interaction in the co-development of encryption. So what we can do here in these applications of cybersecurity, and like I mentioned, this is just an introduction. This is not the mathematics lesson. For that, we would need a separate lesson. But we can already use now what it's called this automated threat detection. That means that in the normal encryption methods, you usually have two separate keys, and then you would have a third party key authentication. Yep, that is usually using, for example, your face if you're using it through your phone, or it's using what let's say an input for a secondary or a tertiary key. But as I mentioned in the example of the micromimic, this is let's say and there's new ways that is creating it as what we call a circular, automated threat detection. So that means in a quantum computer, it is able then to check what would be multi-level attacks. Yeah, so to say, you would have agents that are red teaming together, in order to check, if there's an attack coming from the outside, even if it's a quantum attack. For example, it would be checking for unusual patterns in the network behavior, or any particularly what would be breached through, let's say, someone logging in from a suspicious area, and it would automatically create a response automation. So it responds to the threats, blocks it, and it minimizes, let's say, the damage. For example, if I don't contact the system and tell, well, I'm actually in this other country on holiday, I'm just logging in, then it immediately then switches things off. I mean, but we already have, I mean, response automation is nothing new. I mean, we already have that. For example, banks have it for if they are able to check some suspicions, let's say purchases in your credit card, for example. That is nothing new. What else it can do? It can already look at the limitations and risk associated with AI. So usually nowadays, for example, generative AI is susceptible to prompt poisoning injection. That means that you can manipulate a prompt by creating a hex code, which is completely transparent, and you can put in the prompt, for example, there's some OEM car, I'm not saying which vendor, and you can, let's say, interact with it. It has something like a ChatGPT, this car, and then you can create a hex code that would allow you to have access to the engine management system. So in this hex code would be machine readable. So the central computer will interpret as what would be an operative task from an external diagnostic computers, like that's how garages are able to detect diagnostic codes of cars, and give it then the message link code and the CRC check in order to be able then to get into what would be the entire signal connection within the car, giving it access, for example, to acceleration or the braking systems. So this is one of those output that could cause errors, and also, let's say, this malicious task could cause this bias and errors. So it would make it, let's say, input flow data, and it could impact also what would be then the accuracy state of it, let's say, protecting what would be a secondary algorithm. You have 128-bit CRC, for example, on card networks, and that can be broken quite fast through just an adversarial prompt today, for example. And then it can also learn everything through accessing the central computer of the car, where you've been driving, what have you doing. So it's privacy, ethical, let's say, responsible automation decisions that could be leaked out. So when you want to use it for encryption within, for example, a moving vehicle, that would be another operation. Same moving vehicles today, some of them have access over the cloud. Then you can use, for example, you can only automate and enter the car and use it through, for example, would be a crypto key, so a PQC crypto key that is directly, let's say, configured to your micromimic, for example, and other DNA-based, for example, your fingerprint, iris, etc. So in order to prevent it, anyone else is able then to have an external access, and even within, let's say, the network of the car. That means no internal pre-check, no access, even if it's the vendor itself. So now we're moving into the synergies here of AI. So what can we do here? So because we're creating a new generation and distribution of reinforcing security, we're now able to create what would be this dynamic protocol adaptation. And for this, we're using the machine learning principle that adjusts the quantum encryption protocol to counteract the threats in real time. So to give you an example is that after you're giving it the first pass key, let's say someone would try it through a Schur's algorithm to create what would be a brute force attack in order to check and get your password, which is a typical ESS ECCs. There are just 12 to the 64 on the key encryption level, and a quantum computer for 240 qubits is able to break that once again between 5 to 10 minutes. Then the quantum computer encryption technique, it counterattacks that this particularly key state is changed in the nanosecond level. Yeah, that means that, and it has got a multi-layer. Yeah, so imagine that you just have not just one door to your house and one lock. Yeah, you have 4 3D locks open and closing. Yeah, at the speed of light. Literally, this is at the speed of light level. So it is. You would need 10 quantum computers attacks at the same time just to trying to open one key. Yeah, so I know this is quite complex. Like I said, we would need to look at the mathematics and the physics of that, but this is what is called a dynamic protocol adaptation. Yeah, so and this uses, of course, AI, so the machine learning dynamically adjusts the quantum encryption protocols to counterattack any emerging cyber threats in real time. So another aspect of this is the quantum computing acceleration. It speeds AI algorithms and allows for processing of complex data sets. So in this case here, on analyzing, checking for anomaly detections, and thus having enhanced threat detection, so improves accuracy, and it even identifying, like I said, cyber sophisticated threats. They're coming from what would be, let's say, the US attack, so huge data volumes, and it's able then to, let's say, shut off the door. And so it creates then a Chinese cyber wall, but in this case, this on steroids that immediately can isolate what would be the particularly data aspect. So once it would be check and attack anything suspicious, it simply is able then to subtract the data immediately, put it into a different location in a different database, and isolate it. Yeah, so creating what would be a complete decoupling from other data sources. And yes, data saving at the quantum computing level works completely different. There's no RAM, no ROM as we would think. There is let's say like a lake house, but still structured and connected. But it's a bit more complicated than that. Just to I tried to put in a picture to try to explain this in a fast way. So what else can we do? So in quantum technology integration, it has a secure communication, bilateral encryption resistance to quantum attacks, as mentioned. We can also adapt the communication networks to dynamically detect and counter emerging security threats and create the next generation network resilience. And because it creates this, what would be new type of adaptive and resilient computer network techniques. So it's not your typical TPA protocol. And yeah, challenges, opportunities ahead. So of course, there's still the technical constraints. Yeah, we still face the challenges that limit the performance and scalability for practical applications. There's the infrastructural limitations, as I mentioned, and the robustness and the error connection. Validation still needs to be developed and researched if we really want to be able to have this similar to classical computer in large scale, for quantum and AI integrations. We still have interoperability issues that mean seamless communication between quantum and AI systems still requires addressing this. So, and one way is, like I said, nowadays we're just simply using a simulation, and so over like I said, the HPC core. That's how IBM D-Wave works, in that you're just simply using HPCs to simulate what would be one aspect of the task. But in order to be able to profit from a hardware-based analysis, there still needs to be what would be a better improvement on creating what would be an application layer directly on logical qubits and not on emulation qubits. So that we still have then these compatibility problems. For that, we need material science engineers that are also computer scientists, that are also mathematicians, that are also physicists. So these multidisciplinary experts are still need to resolve these issues. And yes, and this addresses a new threat, of ethical considerations and quantum applications. So privacy concerns. So I wouldn't want to have a blockchain anymore. Quantum systems pose this risk, through these enhanced data processing capabilities. Fairness and bias can now be masked, creating discriminatory outcomes that are masked as true. There is accountability measures. So who is actually now governing for what result, if it's now, let's say, a bit still pretty much black box for us as to what exactly is running behind in the modeling. So we still need to help research and create the frameworks that are going to be essential to govern this deployment and the impact of these technologies. And then, of course, there has to be enforced governmental distribution measures to prevent misuse. And so we need here the development of robust ethical guidelines in order, if we really want to advance quantum AI systems for a societal advantage and not disadvantage. And when anyone with criminal energy having access to these and, for example, creating what would be a massive blackout, or creating and breaking a federal banking system of your country. Imagine, just be chaos worldwide. So there has to be, like I said, a development on this. So particular, we call it crypto governance management, and this has to become a serious concern. The positive side, so there's a gigantic potential for disruptive innovation on quantum security revolution. So you can have now fundamentally create new methods on information with unmatched encryption capabilities, and same thing with, but it needs to be used with the use of AI because of the complexity. But it can also, this can be automated, and it can, of course, transform all information processing, because now data can be analyzed and protected at scale within seconds, data that would take hundreds or thousands of years literally to be able to be analyzed, giving us completely endless possibilities on their research and advantages. So what else then we need to prepare, and what we need also to ensure, is that governance prepare for a security policy adaptation and infrastructure investment, and as well as a regulatory framework. So industries, universities need to provide and help and bring on, let's say, the and take the leadership together on addressing as the experts on this field and advising the governments into creating these policies, and also then on infrastructure investment. I mean, I know India alone has got another $4 billion USD on investment on quantum computing, but nevertheless, let's say you are the thought leaders of the future in this case. You are allowed, in that case, it's from your leadership in research management to help create and manage these regulatory frameworks, and also in addressing the operational challenges, and of course profit from quantum innovations. So then, of course, further skills in quantum computing. So this is one way of starting it, and also still keep building the AI skill development. So no, even agentic AI and all the new advances in AI will still not replace the need. We need different and new models for this, as well as cybersecurity proficiency. So what needs to happen here is that there has to be new modern education programs to adapt and prepare a skilled workforce for these emerging tech fields. So this is a critical aspect. So recommendation is, of course, then to invest in research and foster collaborations. And this is nothing that can be done alone. There has to be academia, and that's why we work together in Europe and also with the USA. And also in order to create this adaptive security, because this is something that needs to be ensured now. It takes good 3 to 5 years for a transition, depending on the budget and of course the complexity, and also to create and start now on engaging in policy development. So to create the governance and quantum technology in the futures. So in short, quantum security has an impact, and it offers wonderful protection techniques for future digital infrastructures and privacy, and there's a lot of integration benefits. It allows and enhances threat detection and response, complementing security advancements, and prepare for strategical future development and be able to harness AI benefits effectively. And from this, I'm finished on this introductory session, and then the next session I'll jump directly then into the mathematics of this. And I thank you all very much for your attention.
Thank you, ma'am. Thank you.
Apologies, I've got to go, sorry.
Yeah. Ladies and gentlemen, we would like to share an important announcement. Dr. Catherine, Chief Data Scientist and AI Director, Global Growth Markets, Cognizant Switzerland, had to step away from the ongoing session due to an unforeseen contingency at her head. We sincerely regret the inconvenience caused and extend our apologies on her behalf. We truly value the time and attention of all the participants. However, the discussion remains open and we will be glad to address your questions. So please feel free to share your queries in the chat. Our esteemed panel will ensure that the questions are taken care of and responded to. Before we move to the next session, I would like to highlight the important points which are required to be discussed before going for the examination tomorrow. As discussed, accordance to AICTE regulation, attendance is being monitored through the feedback system during each session, and minimum participation rate of 80% is required for the successful completion of the program. Most importantly, the final assessment, which is scheduled tomorrow, would be conducted from 6:30 p.m. to 7:30 p.m. Many of the participants were asking regarding the format of the test. It is MCQ format, covering various sessions being conducted right from day 1 till the last session. But rest assured, the test is not so tough, with average questions which would require each one of you to have a mandatory score of 70% to qualify. And to be more precise, we are very confident that each one of you will get through. Once the test is given, all the participants are required to again log in and complete the feedback for the FDP. It is mandatory and it is within the designated time frame. Let me put across the assessment as well as the feedback has to be completed through your ATAL logins. Then we have a valedictory address 2, which I request all the participants to attend, which would be considered again for attendance. On Monday, once the co-coordinator updates attendance day-wise on the online portal, we will inform the participants and they can start downloading the certificate of ATAL of completion and participation. We sincerely appreciate your cooperation in adhering to these guidelines. It is my privilege now to move to the second session, and I'm honored to introduce to you a visionary leader who has seamlessly blended technology, leadership, and human potential across the globe. Dr. Tejpal Singh Batra. With over 30 years of experience, Dr. Batra has led global teams across 72 plus countries in IT, operations, human resource, and talent development. He is the founder of SSO Consultant, where he continues to drive people, process, and technology transformation for organizations worldwide. His entrepreneurial spirit also shines through ventures like DataOwl, Edge Platform, pioneering in AI data and analytics, and I Give Life, an NGO that reflects his commitment to social good. Academically, Dr. Batra holds a PhD and an MBA, along with professional certification in predictive index, ATAL, and Prince2. His expertise spans AI, digital transformation, process excellence, analytics, leaderships, coaching, and design thinking. He has been a visiting faculty at top business school for a decade, shaping minds in AI, analytics, operations, HR, technology, and even sports tech. His impact as a trainer and facilitator is evident from having certified more than 2,000 students and 350 plus corporate participants in AI and analytics. What makes Dr. Batra truly remarkable is the ability to blend AI, analytics, and organizational progress into strategies that not only drive business growth, but also customer engagement. Ladies and gentlemen, please join me in welcoming global leader in AI, digital transformation, and innovation, Dr. Tejpal Singh Batra. Thank you, sir, for joining us today. We look forward to your words of wisdom, and over to you, sir.
Hi, good evening. Thank you. I hope you can hear me.
Yes, sir.
Great. And it's a pleasure to be with all of you. And I hope you can hear me, and I hope I would be able to hear you too. I joined in a bit early, so in case somebody noticed, and I was listening with uh, great attention about quantum and what the future holds. And it is indeed amazing, same as generative AI. So I had a small question out here, right? I just heard that you're gonna give your exam and you're gonna go back, and then I hope all this learning would be put to practice. So if I have to ask you, what are the two things you think you will do when you go back, which will use generative AI? Sir, will they be able to talk to me?
Yes, sir,
Hello?
they will be able. Yes, sir, they will be able to talk with you. So we will unmute the
Yes.
person who wants to give a response. Yes, ladies and gentlemen. You can raise your hand and we will unmute you.
And while you think and make up your mind whether I'm worth talking with or not, I think the key part is that if you have to, when you go back, it's all about implementation, right? So I would love to know where you think you will be able to use this.
Dr. Mittal has raised his hand. Dr. Deepak, can you please unmute him?
Hello, good evening, sir.
Good evening,
Good
ma'am.
evening.
Yes, Dr. Mittal here. Sir, I will utilize whatever things I've learned in this FTP for content creation, for the development of contents for my classroom. That would be the one thing. And second thing, I would also be utilizing that for accelerating or enhancing the research work. These are the two areas where I would like to implement the things that I've learned in this FTP.
Amazing, Dr. Mittal, and I would can I take the liberty of coming back to you in few minutes once I hear from your other friends too.
Yes, sir. Yes.
Anyone else? Right, while you think, uh, let me put forth some points. So yeah, I work with the industry on implementation of AI. And I think the key focus as of now, when I say industry, that is both educational institutes as well as the corporate. I think the focus now is how can we implement AI, generative AI, and how can we get most out of it? How can we improve? It's not only about being more fast, but how can we do things in a much better, much better way. That's the key. So a few examples which Dr. Mittal said. Yeah, let me put things into that perspective, right? Making content, yes, Dr. Mittal. So uh, let me know if I'm on the right path, and then we can now will involve everybody else in talking into it. Yes, getting a better content should be good, should be faster now, right? Because I think you have been taught prompt engineering and everything else. That should happen. I was also told, you guys have been told how to fast track your research. Great. Now let's come to content. We will make the content which will be much more richer, much more in depth, and then we will give it to our students. Am I right? In the classroom, we'll talk
Mm,
about it.
Yes, sir.
Yes.
Yes, sir.
Yeah. And when it's the time for exam, let's say an MCQ, they will use the same enhanced content to take it to ChatGPT and try to figure out how are you making your MCQs, right?
yes, they would use it. So, may I interrupt? One more thing that
Yes, please.
I forgot to mention is that making students more engaged and making them use AI will also be one of the way where I'll be utilizing the things that I've learned, like
Perfect. So
conducting assessment, right?
exactly. So few thought processes out here which are being implemented or experimented in the educational arena as of now. And I'm just putting food for thought, and I hope that that motivates other participants to unmute and talk to me, or they can put up on chat, and maybe somebody could be kind enough to read it for me. Would be so, Dr. Mittal, I'm addressing you with your permission. What if we
Yes, sir.
use
Yes.
generate? So what if we use generative AI in a way that you make your enhanced content, but in two parts? Because we know our students are using AI, and we know our students are much more expert in using AI because they use it all the time. So what if the content was made in two parts? One was to explain the concepts. Let's say, for example, the speaker before me was giving an amazing example about how the encryptions works in quantum, how will the blockchain work, how will everything else work out there. That is explaining the students the whole concepts, right? But all the examples which are given out there, what if they were only explained in the class and they were not in the notes? And I think I'm trying to bring a point out here of how to use AI to protect yourself from AI being used against you. And that's a very good use case as per me, is that in the class, when you are engaging them in various activities, you take examples which only the students in the class are aware of. And when you go back and use AI again to make your MCQs, you are combining both the sets, one which is with you and one which is with the student. Now, and then you can tell AI who's making MCQ for you that do a 50-50 combination or a 60-40 combination. Won't that be a way where the student then will know that they can use AI because you're allowing them to, but they need to be in the class to know the relevant examples, because without that, AI also won't be able to help them. What is your thought about it, Dr. Mittal?
Yes, sir. That will be a great thing to do. I mean, it will ensure participate in the class as well as they will understand that everything is not available over there. So that will be
Ex-
the thing that we can work on.
Right, and that's where I believe you guys learned prompt engineering, and I think that will come massively into play because all the various uh, AI models, and I believe you guys were taken through the various models, LLMs and SLMs. We guys are aware of what are LLMs and SLMs.
Yes, sir. Yes.
Perfect. Uh, Looks like it's only you and me. Other friends are just happy to let us talk, and they are listening. That's great. Now, if I may ask one more question, when you guys go back, you're going to use prompt. If I have to ask you, what are the 5 basic principles of using prompt when you are back in your seat? Can anybody put those 5 principles of effective or efficient prompt engineering on chat for me? By the way, I'm not taking your MCQs out here, but this is how it works in the industry. So if you have to write an effective prompt, what are the 5 things you should know? Whether you're from STEM, non-STEM does not make a difference. You're using quantum, non-quantum does not make a difference. But there are 5 principles if you have to use AI in a way where you are in control. Can anybody take a jab at that?
So someone has written in the chat box as context.
Context. Great.
Yeah.
Okay. So is that sufficient, or is it still he or she still thinking about it?
And they have written something else also. Being precise, guiding the AI on examples, clarity, context. The 5 principles are persona, context, role, be clear and specific. This is written in the chat box.
Great, great. So, ma'am, I'll say something. Would you be able to put up on chat so other people can also see?
Ji, sir. Yes, sir.
Right. So, I think the friend who said the first one, absolutely right. The one thing to be in control and not generative AI hallucinate or take control of your conversation would be always start with the context. Always
Okay.
let AI know what is the context of what you're going to ask it to do. So the first one is context.
Okay, sir.
The second one would be the task you want it to do. So that's the second part.
Okay, sir.
The third part would be the instruction on how the task should be done.
Yes, sir.
And clarify few things which you want the AI model to know on what was your context, in case you think you need to clarify few more things. So
okay,
it is
sir.
context. It is context. Okay, then it comes to task. Then it comes to instruction. Then it comes to clarify.
Okay.
And then you execute your prompt. Once you get the output, so 4 are important straight away. And once you get an answer, you don't like it, then you use the 5th one, which is refine, where you then say, no, I want you to change this, I want you to change that. And if you use this 4 in a go, you have to always start with the context. The remaining sequence can change. AI is smart enough to understand, but always start with the context, right? So that's the key part. And before I go ahead, because this is the first time I'm talking to all these amazing people, are they okay with this practical approach, or they are not? So that I can decide what kind of engagement I have to do.
Sir, there is a person who has raised the hand. Can we unmute her?
Yes, please.
It is done. Unmuted.
Yeah, Professor, I'm Dr. Aklandeshwari. So
Yes,
you
ma'am.
mean to say clarifying on the task with an examples or references something?
Yes, it could be that you have something very specific in mind. Like I'm just thinking on the fly that you are talking about something where you want a background has to be blue, right?
Yes.
But you can then say it's a blue which Amitabh Bachchan wore in that picture.
Okay. Okay.
So it will go and check that and give it to you.
Okay.
So it could. So that's the meaning of clarify, and sometimes you need to do that. Right. So, and you are also right. Second thing could be an example, or you could give, here is an existing output which I have. I want you to work on something similar.
Yes.
So it could really work, right? So I think that was an amazing question on what we need to do. And
what I have, what's my actual clarification is, if in case I'm just giving you writing a prompt, asking something, and it should not deviate from my point, right? So for that case, if I'm giving some references or some form which I want exactly, so then it will be something relevant to what I'm expecting, right?
exactly. So you're, ma'am, that's why you have to give the context, which will tell what you're thinking. Then you give a task which is in line with the context.
Okay.
Then you give instructions on how to do the task in line with the context.
Mm.
Then you give a clarification which will further clarify the context to the LLM or the SLM.
Yes.
And once you get the output and you think it's still not understanding, then you give refine, saying that, okay, here is one more example maybe, or here is the format again, and please do this to me.
Right. Okay. Thank you, sir.
Right. Now, my question to you. So thank you very much for asking that question. Now the question for all. After prompt engineering, did you try making some prompts in that line? Can your work be done with single prompt? It's a question to everybody. You want to do something, can you write one prompt and get it done?
No.
Yeah, that only happens on Instagram Reels. Real life does not happen because you need to, so that's why it's called as generative AI, which basically also means that you have to talk to the AI. Have a conversation, and then try to get your work done, because that's where AI gets a much better clarity on what is happening and how it is happening. Are you guys okay for a quick small activity? Will you guys be game to do that for me and put few things in chat if I request you to?
Yes, I think the participants would love it, because I have one comment in the chat box which says this approach is very good for the session. It is very interactive. So I think we can go ahead with this. Definitely.
Virtual high five to that participant, please.
Sure, sir. Sure, sir.
Right.
Yes.
Okay. So a question out here. You guys, I just heard sir who so kindly introduced me, saying that you guys are gonna do your MCQ and then you're gonna pass FDP and all that stuff. A simple task for you is use any AI which you use, draft a prompt which will make a LinkedIn post saying that you have successfully completed ATAL FDP. What prompt would you write to get an output which will give you a LinkedIn post? Do you want me to repeat?
So I'll write the question in the chat box.
Yes.
Which prompt would be given for a LinkedIn post, right?
Yeah, LinkedIn post about successfully completing ATAL FDP on AI, or whatever the topic is.
So I'll put on dash, whatever be the topic.
Then, madam, ek dal do, taki I want sabka prompt to be same. I want everybody's prompt so that they are.
Okay, so you want me to write the title of the FDP in that.
Just you can you can write FDP on AI and quantum, whatever comes.
Okay. Yes, got it. So on next gen technologies.
Yeah.
In action. Generative AI.
Yeah.
Okay. So I have done that. So let's see for the responses.
Yes. Couple of minutes. It's AI, so we should be fast.
Yes, sir.
We'll wait for a couple of minutes. Yeah.
Yes, sir.
And do remember, I need the prompt. I don't need the output. You keep the output with you, but I just need the prompt.
Oh, people are giving the output actually. Participants, we need the prompt. What did you write in the AI that you have used? Sir, I will read out one person has written, Mr. Vijal Thakkar. write a LinkedIn post as I have completed ATAL FDP on next gen technologies in action, generative AI.
Okay, great. I think one, two more would give me a very good context about how everybody is thinking.
So another one has Dr. Namrata Deshmukh has written, create a post LinkedIn, successful completion of ATAL FDP on AI and quantum. Dr. Pragyadipta Das has written, write a LinkedIn post announcing successful completion of ATAL FDP on next gen technologies in action, generative AI.
Perfect. I think enough for me to look into it. Now, few observations. One, in this case, aren't you giving AI the freedom to think whatever it wants without any context and give you any output? And if I'm not wrong, I'm not looking at any output. It would have a lot of emojis and it would have the text would be longer. Would that assumption be right with the participants?
Yes, I think so, because one of them had shared the output, so there were certain emojis. And yes, it is talking about some topics are mentioned. And thank you and etc. And thanks to AICTE. Hey, please, we are also there. Sadhu Aswani Institute of Management Studies is also there.
Right. Okay. So great. So each of you, and I think many others would have also executed, and they would have it with them. Would you want to experiment for a prompt with me now?
Yes, sir.
I will. Ma'am, my apologies, but I'll say you will have to type so that.
Sure, sir. Definitely, I'll do that.
Yeah. So we write. You are an expert in social media content creation.
Yes, sir.
Especially for LinkedIn.
Okay.
Full stop. Space.
Okay.
Do you understand? Do you full stop space? Do you understand? Answer in yes or no only.
Just a minute.
Yeah. You are an expert in social media content creation, especially for LinkedIn. Full stop. Do you understand? Answer in yes or no only.
Okay. So I put it in the chat box. So yes, I have to use this prompt in the AI that I'm using.
Yes.
Okay. Let me also try.
Yes, please. I was somehow hoping you will do that. So.
So the answer is yes.
Yes. And so first of all, we have taken control on how much will AI speak to us.
Okay.
We wanted answer in yes or no. So it is only telling us yes or no.
Yes.
So
agree.
That's first. Now, especially all of you will go back and do amazing work for your organization, which is very important. So it's very important for us to understand what has AI understood. So now we have to say, tell me in short, what have you understood?
So I have to write this in the chat box.
Ji, Madam Ji.
Tell me in short what you have understood.
Yes, what you have understood.
Okay. Fine. I have written it. Okay, done. So we have to put this in the AI also?
Yeah, yes, yeah, AI also. You're putting on the chat because others can also execute, right?
Okay, yeah. So
now you put up in your chat. Now, what's the answer?
In my AI, it is saying you want me to act as an expert in creating LinkedIn content, meaning I should help you craft professional, engaging, and effective post tailored for LinkedIn audience and platform. This is in my AI prompt. That is the response. And some people have written.
Yes. Yeah.
And
Sorry.
Vijay Lakshmi S has written, you want me to create and guide social media content specially tailored for LinkedIn. Swaraj College has written the responses. I have understood that I should act as an expert in social media content creation, especially especially for LinkedIn. Vijay C has written, you want me to act as a LinkedIn content expert, help you to create short, engaging and professional posts like for achievements, events.
Enough.
Yeah.
So
Okay.
would you agree? Would you agree? In all, it is all tomato and tomatoes. Same. Now, all of you are at a different location, but one prompt has ensured that your AI now is thinking only like a LinkedIn social media content creator.
Correct. Agreed.
It won't look left or right. That is called context setting.
Okay. Nice.
This is how we do stuff, where we put the context. Now, for it to go left and right is very difficult, right?
Yes, sir.
Right. Oh, great. Now, when I take my name, ma'am, it's your name, and for participants, their name. Right.
Ji.
So let's write. Tejpal has approached you.
Okay. Just a minute.
Yeah. Each of you would be your name. So.
Okay.
Tejpal has approached you to write a short and impactful post on successful completion of ATAL FDP. जो भी था वो एक बार बता दीजिए please.
Yes, successful completion of ATAL FDP.
Right.
Next
Full stop.
gen. So I have to write the title.
Next gen. Yeah.
Next technologies in action. Generative AI. Sir, I will also add organized by Sadhu Vaswani Institute of Management Studies.
कर दीजिए मैडम जी.
Yes, sir. Thank you so much.
By the way, guys, all of you now would have a post ready to be posted the moment you get your certificate. So after this, right? Ma'am, would you mind repeating if you don't mind?
Tejpal has approached you to write a short and impactful post on successful completion of ATAL FDP dash Next Gen Technologies in Action, Generative AI, organized by Sadhu Vaswani Institute of Management Studies.
Great. Only a reminder, for me it was Tejpal, for you it should be your name, and for others they should be their name.
Okay. So I will write Divya has approached you. Okay.
Yeah. Right, done.
Yes.
Full stop after last line, last word, full stop.
Okay.
He also strongly feels.
Okay.
Something like this will give him the edge in his future growth.
Okay.
Full stop, space.
Okay.
He also wants to use this to increase his visibility and future collaboration efforts or chances.
She also wants to use this, na?
Yeah, use this to increase her visibility. I'm talking on your behalf, her visibility as well as potential collaboration chances. I can't use the other word which you guys are understanding, so I'm using the word called collaboration.
Okay, sir. So I'll put a full stop and then enter.
Yes.
Okay.
Now each of you can see the output and then look at your earlier output and tell me, is there a difference? And if yes, then what is the difference? Is it now talking about your other parts?
Yes, sir. In my case, it is so with the emojis. Thrilled to share that I have successfully completed so and so, organized by so and so. This program gave me such valuable insights into the transformative power of generative AI and its real world applications. I truly believe that staying future ready with such emerging technologies will give me an edge in my growth journey. I look forward to leveraging this learning for impactful initiatives, knowledge sharing, potential collaborations in this exciting space. Along with this, the hashtags are also given.
Yeah. So for my other friends, participants who had executed their own prompt first, would love to know, are they seeing a difference between the prompt they did and we did, and was the second output better or was worst?
So, ladies and gentlemen, please write in the comments section which one was better, first one or the second one. In my case, definitely the second one was better.
And you can even tell them even a smiley will do. We'll understand. We are smart people.
Yes. Thrilled. Yes. Yes. So majority are saying the second one is good.
Yeah. Welcome to AI. Welcome to prompt engineering. This is how you start. Right? Now we can just take it to the. I'll take two more things from this, ma'am, with your permission. So
sure,
then
sir.
This example would be over.
Yes,
now,
sir.
Let's just type one more thing.
Yes, sir.
If you are in the mood, you have to type it, ma'am.
Yes, sir. Yes, I'm doing it.
Yeah, if you are in the mood.
Yes, sir.
Can you help generate an appropriate image to go with this post?
Okay. So
right?
If
not, if not, we have to take care of people's mood, including AIs. So, if not, then give me link of a site from where I can download appropriate image. Ma'am, would you mind repeating it?
Yes, sir. So 1 minute. Yeah. If you're in the mood, can you help generate an appropriate image to go with this post? Full stop, space. If not, then link of a site from where I can download appropriate image. Full stop.
Yeah. Let's press enter. And by the way, for everybody, this example is spontaneous. So I'm sorry if it's taking a bit of a time, but knowing what you guys are doing, I just thought to introduce this example. Now, depending on everybody's Wi-Fi speed, I think we should get response in a couple of minutes. Or मैम आपका आया?
सर मैं देख रही हूँ एक बार मैंने खाली एक ही वर्ड टाइप किया खाली इमेज तो लेट मी कॉपी द फुल सेंटेंस एंड लेट मी ट्राई.
Yes.
The answers are Unsplash, Pexels, Pixabay, Shutterstock, iStock by Getty. So these are the websites from where we can get the images.
Yeah. Was anybody able to get the image?
Yes, someone has put it in the chat box, some images. Where a learning office type of atmosphere is there. People are brainstorming, someone is speaking.
So see what wonders can you do with prompts?
Yeah. Okay, and then someone has shared a link from where they can get the image. मेरे case में, yeah, I am able to download. Something went wrong while generating an image. Maybe the internet connection is not so strong.
Yeah. For this, I took the liberty, but it is only because the speed would be.
Yeah. Correct. Yes, sir.
Now, a thing to everybody: are they able to understand the context, the text, the task, the instruction?
Yes. In fact, Dr. Agilesh Deshwari has given a beautiful image of AI. Wonderful image. Wonderful image.
Perfect.
Yes.
Now, because I think it's a long day for everybody, right? We can make them smile with the last prompt of this example. just to tell them how you can change the context and get anything done.
Okay,
Right?
sir. Yes,
Now
sir.
say, I want you to think like.
I want you to think like.
And think of any singer you have. So let's say I'm saying I want to think like Badshah and make the post accordingly for Instagram.
Acha, for Instagram. Okay. I want you to
Madam,
think
LinkedIn
like.
pe Badshah won't work, na? Yeah.
Okay. So will it understand कि it has to go for Instagram?
डालिए ना आप.
Okay, I want you to think like
सुनील को
Badshah.
बुलाना.
Okay,
Yeah.
Badshah लिखा है
सुनील को
मैंने.
बुलाना, कुछ मंगाते हैं.
Yeah. Would you mind repeating the line again? Or
Yeah.
also type on the chat.
Yeah. I want you to think like Badshah.
Singer Badshah. क्योंकि
Singer
Badshah also
Badshah.
might mean, yeah,
Okay,
singer Badshah.
Okay.
And make this post now for Instagram.
Okay, so let me. मैंने enter कर लिया था, तो I will just rephrase and type it again.
Yeah.
I
But
want
for others,
to
have
think.
you put up?
Yes. Like singer Badshah and prepare post
वो
for
बैग और उसका ठेचा मांग के लाना.
and post for
bag.
Instagram.
Yeah.
Yes.
Are we getting something?
Yes, we are getting. Now there are lots of more emojis actually. All
Obviously,
right.
Badshah comments in.
Yeah. Yo, level up unlocked. Oh my God. Just dropped some serious tech heat. Wrapped up ATAL FDP on Gen AI. Oh my God. Hosted by Sadhu Vaswani Institute. Big ups to the legends behind this. 6 days. Next gen knowledge. Game-changing tech. And now I am ready to roll with the future. This isn't just a course. It's a power move. Fuel for the hustle. Edge for the future. Let's innovate, educate, and collaborate. If you're talking AI, ideas or innovation, slide in. Let's build something wild. Oh my God, the response is entirely different now.
Exactly.
Yes.
Let's see what our friends have to say. Are they seeing Simtha? Did somebody try somebody else and did they get something?
This was a response by Prapti. Then Vijay C has something like wrapped up the ATAL FDP Next Gen Technologies in Action, Generative AI at Sadhu Vaswani Institute of Management Studies. This journey wasn't just about tech, it's about staying future ready, chasing growth, and creating space for new collabs and ideas. Big love to the mentors and fam who made this happen. The grind continues, the vision gets sharper, and then the hashtags.
Great. So, can you see how just by changing a context, you can get a completely different output?
Yes, sir. Absolutely. Just loved it.
And throughout this 20 minutes of our talk, if I may ask, who was in control, AI or us?
That's a question that I would like to put to the audience.
Yeah, ask them for this whole exercise. Yes, who was in control, AI or us?
Okay. The prompt was in control. Us is the response. We are in control. And someone has said that AI is in control. AI is in control.
No, by this context, when we said LinkedIn, AI could not dare write an Instagram post for us because we were asking it to think only for LinkedIn.
Sir.
There was no yo, no fam, nothing. The moment then we said go to Insta, it forgot about LinkedIn and worked for us as Insta.
Yes, sir.
So this is how we stay in control. And the key part when you go back is that you have to remember that you are taking the lead, not the AI. The moment you let AI take control, you lose the focus. Ma'am, you might lose me for 10 seconds. So please
Yes,
bear
sir.
with me.
Sure, sir. Sure, sir. No worries.
Till then, you can ask for some more views. If they have seen something, some comments, some question they have.
Yes. Ladies and gentlemen, if you have some more responses, we have few more questions, you can put it in the chat box. We will have the next session starting at around 7:30. So please put your questions in the chat box, or you can raise your hand and then we will unmute you. Yes, any questions? Please take an example to understand refined principle as well. We have a question by Dr. Namrata Deshmukh also. Yes. Okay, so we want to take an example to understand refined principle in the same example. Okay, fine. Concept of confusion while answering a question by AI. Okay. Ladies and gentlemen, you must have seen the amazing responses that we got when we tried this on the respective AI models that we have used. I'll just read out one of them. Sun ke dekho, just wrapped up the ATAL FDP on next gen technologies in action, generative AI at Sadhu Vaswani Institute of Management Studies. Generative AI isn't the future anymore. It is the now. Skills, growth, collabs. Big love to everyone making this learning journey a banger. Ab agli kahani innovation ki hogi. Oh my God, I just love this way, the way it shows. So we have few questions. So let Tejpal sir join. Tejpal sir is there. Maybe he's not in the range. So let's wait for him to resume. Then we can get back to the QA.
I'm there.
Great, sir. So there is a question. Please take an example to understand refined principle as well in the same example.
Right. I said Badshah, you can go back and say redo and do in Harry Potter style.
Redo and do it in
redo in Harry Potter style.
Redo in Harry Potter style. Okay.
Other example could have been don't use more than 3 lines.
Okay.
Or could have been just make it 4 line.
Okay.
This is how you refine. Are we getting Harry Potter now?
Yes, anyone has tried it in the Harry Potter style?
You have any other questions in the chat box still there?
Yes, sir. There are two. Dr. Namrata Deshmukh has raised her hand. Dr. Namrata Deshmukh, please go ahead with your question. Dr. Namrata.
Did we lose her?
I think so. She had written something like too much of typing was as good as writing a post. So can we give specific word?
No, very great. Tell her a brilliant question, but tell her, what if you have to write it once and save it with you, and for next 10 years, any new certification you do, just go and change that context.
Okay,
Welcome,
unmute me.
welcome to Agentic AI.
Okay. Deepak sir, can you please unmute Dr. Namrata Deshmukh? She wants to have a discussion.
Just a second, ma'am.
Yes, sir.
Namrata Deshmukh.
Yes, sir. Dr. Namrata Deshmukh.
Just a second. Done. Namrata madam, you can ask your question.
Hello.
Dr. Namrata.
Namrata madam, I have unmuted you. You can please ask your question. Dr. Namrata Deshmukh.
Till then, ma'am, any other question?
No, I don't
Okay,
see
anybody
any.
else wants to ask any question?
Till
Madam,
that
I have
time,
unmuted you. You can use your mic.
Hello, am I audible?
Yes,
Yes,
ma'am. Yes,
madam.
ma'am.
Yes, ma'am.
Yeah. Actually, I just wanted to say that when we give so much of specifications, specifically in that case where we have also mentioned about the collaboration and all, right? So FDPs or creating a post every time will keep on changing. So the content will also needs to be reframed likewise.
only the
So every
content. So if you save this prompt, I think it's an amazing question. And it will take me to the next step. So thank you for that. If you want to save this prompt in Word, next time if you're doing any certification, you change only that detail. Remaining all remain the same.
Acha, okay.
Now, ma'am, यहाँ पे एक और काम करते हैं. What if with a prompt? What if with a prompt like this you all papers? Then will it be worth it?
Prompt on? Sorry, we missed you.
If you had a prompt, where you could give a paper, question paper.
Okay.
You could give your rubrics. And then give 200 papers, and it could check all the papers for you. Then would that prompt be too long, or will it be worth it? Yes. So that I did this on the spot, and only to bring you here that yes, for a small thing like a post, it may look bigger, but for a paper check, I think you won't mind writing even few pages, right?
Of course.
Now I'll share with you. In the morning, I was in a workshop on research, right?
Okay.
We wrote a 12.5 page long prompt for writing synopsis.
Oh,
but after that, in 20 minutes, you can make any synopsis.
Okay.
Will that be worth it?
Of course.
And I think that's what that's where all of you should be going back and say, can I reach there? And the starting point was LinkedIn. And again, me being me, I can't let the chance go. Jo pehla prompt tha, that was making steam rice. My prompt was like a biryani, so usually takes time to happen, but then the output is much better.
Sorry.
But yes.
We were impatient audience.
Yes.
Sorry.
Yes, and I love that, because in AI, your students are much more impatient, right?
Right.
So my take out here would be, my humble request would be, go back and see, can you change the way you make your content? In your MCQ, see if you can segregate both of them in such a way that the students need to come to class to know the practical aspects. Explore, can you check papers with this? Explore, can you make cases where you encourage people to use AI, but then in the class, they have to tell you the context.
With MCQ, sir, actually, I have tried that. So it drafts very nice MCQs. Yeah.
Yes.
Thank you.
So thank you very much for the question, ma'am, and I hope I was able to throw some light on it.
Yes, of course, sir. Thank you so much.
Ma'am, anything else?
No, sir. Thank you so much, sir, for your wonderful session. And I'm sure the audience has loved it the way I have loved it, and the way the prompts were differently conducted, and the way we actually saw the output. It was a very enlightening experience, and I'm sure we will be implementing all these things in our daily academic life. Thank you so much, sir, for sparing your valuable time and guiding us through the nitty-gritties of the different prompt engineerings that can be adopted. Wonderful, sir. Thank you so much, sir, for being with us.
A pleasure, and thank you, everybody, and have a nice evening.
Thank you so much, sir. Thank you.
Bye-bye.
Bye, sir. We now have the next session of the day by Mr. Rajesh Kode, sir. Good evening, everyone. It is my pleasure to introduce our eminent speaker for today's second session, Mr. Rajesh Kode, Senior Vice President, Technology Infrastructure at Northern Trust Corporation. Today, he will be sharing his insights on the highly relevant and critical topic of cybersecurity and AI integration. Sir brings with him over 3 decades of accomplished experience in the IT industry, during which he has led global teams, designed robust IT strategies, and managed large-scale technology infrastructure for leading multinational corporations. In his current role at Northern Trust, he spearheads IT strategy, governance, planning, budgeting, and deployment of infrastructure services across the Asia-Pacific region. He also plays a pivotal role in digital transformation, IT operations, and automation initiatives, contributing significantly to the organization's global growth and resilience. Before joining Northern Trust, Sir held senior leadership positions at renowned companies such as Fiserv, SunGard Financial Systems, KPIT Cummins, Deutsche Bank, Hindustan Lever, and Robert Bosch. In these roles, he made notable contributions to the establishment and management of data centers, cloud operations, managed IT services, and business continuity solutions. Academically, he is a graduate of the University of Pune, holding an MBA in marketing and another in operations research and systems, along with a bachelor's degree in computer engineering from the Maharashtra Institute of Technology. He is also a published author with his white paper on remote web content filtering, highlighting his expertise in information security and remote computing. Widely recognized for his visionary leadership and a passion for innovation, Mr. Rajesh continues to inspire professionals by demonstrating how technology can be leveraged to drive business growth, digital innovation, and operational excellence. Ladies and gentlemen, let's join hands together to give a warm welcome to Mr. Rajesh. Over to you, sir. Deepak sir, can you please unmute the mic of Mr. Rajesh?
Rajesh sir, you please check.
Can you see me now?
Yes, sir. Yes, sir.
And can you hear me?
Yes, sir. We are
Yes,
able
sir.
to hear you. Yes, sir.
Okay. Great, and thank you very much for that introduction. Let me give a quick brief about myself. So, myself, Rajesh Kode, and I think you have already briefed me, and you have not left anything to cover for me. You have given a complete insight about myself, but I would like to really talk about myself a little bit more about as to what has been the achievements and specifically connected with the topic of cybersecurity. So I've been working in the IT industry for more than 3 decades now. It's close to 35 years in the IT industry. Having the opportunity to really look into the industry from being basically getting into something like mainframes and ICDs to now into the cloud computing and the digital transformation. Had a chance to basically work with various multinationals and had a chance to set up 5 captive centers in India, most of them in Pune and Bangalore. The captive centers that I've been currently working and I'm setting up is for Northern Trust. Northern Trust is an investment bank, one of the largest investment banks in the world, headquartered from Chicago. And here we basically are setting up a technology capital for Northern Trust. We are at a location where I think 60% of our overall delivery is now happening from India. Similar initiative that we have driven, where we have set up a captive centers for SunGard Financial Services, SunGard Availability Services, which is again a financial services product companies, as well as data center, cyber, and recovery services service provider. It was pioneers in the entire globe for basically providing BCP and DR services. I've been also instrumental in setting up Deutsche Bank's offshore India and Deutsche Networks, which was the first captive for Deutsche Bank. It was also instrumental in setting up the Hindustan Unilever's first captive center way back in 1998, which was one of the first few captive centers in India. And as far as cybersecurity is concerned, in fact, the experience has been basically setting up at least 6 to 7 security operation centers way back from 1998 onwards. Basically set up the first security operation center for Hindustan Unilever, covering close to around 36 countries and the region, Asia Pacific region. I also had an opportunity to set up the Global Security Operations Center for Deutsche Bank, covering the overall Deutsche Bank security globally. I also had an opportunity to set up a similar SOC for SunGard Financial Services and SunGard Availability Services. I had an opportunity to do the penetration testing for Pentagon and basically was able to crack some security protocols for one of the highest authorities in the US. Also had an opportunity to with Fiserv when I was actually heading the IT for setting up a forensic center for social security and was able to recruit most of the people from CBI to set up this forensic security. A very unique opportunity, a similar one that I'm now doing it for Northern Trust. We are setting up a global security operations center for Northern Trust as well. However, when we do all those things, what I now know is basically our landscapes in cybersecurity has drastically changed. What I did in 98 and 2004 is no more applicable anymore in our current scenario when it comes to cybersecurity. What we are really going to cover today, how the whole landscape has changed in cybersecurity in the age of AI and quantum computing. Especially what I'm going to present you is a very forward-looking presentation, which is where AI and ML is something which is where we are actually using in cybersecurity. But how quantum computing is going to really change the landscape in cybersecurity is something which is what we will be really covering today. And it's a very interesting landscape because there has been a drastic change in the way cybersecurity is really to be seen, especially in the quantum computing era. Along with you, we're also learning together. If you have any questions, I'll pick it up at the end of the session. Definitely be able to answer it to the topic that we're talking about is an evolving topic. So even if you have anything to really add up, I'll be ready to listen to you as well. Let me share the content. Let me know when you get to it. Are you able to see it?
No, sir.
Hello.
Yes, sir. Presentation is
Able
visible.
to see it, right?
Yes, sir. Yes.
Okay. Perfect. So the topic that we're going to cover today is about talking about cybersecurity in the age of AI and quantum computing. Now, traditionally, if you look at it, the age-old security that we usually manage has changed a lot, especially after the COVID era. And why after the COVID era is because traditionally we used to work from the offices. And when we used to work from the offices, our perimeter was restricted to the office perimeters or the office networks and office physical areas of the office. Logically, in fact, it was secured with the perimeter. With the COVID era coming in, after COVID, these logical securities and the physical securities is no more, the boundaries are no more valid anymore because everything has become distributed. And when he said everything has become distributed, if you look at it, we have started working from home. We have basically started using laptops, mobile devices very extensively for basically for our office premises and for our office work. Similarly, our traditional perimeter of our office network is no more valid because the perimeter has gone to your endpoint devices, which has become our perimeter is now our laptops. Our perimeter is now our mobile devices. Our perimeter has gone to something like on a cloud. So the traditional security is no more valid. That is one. Second, if you look at the evolvement of the overall digital transformation that we have, especially on the cloud side, most of our organizations are actually moving up from on-prem to on-cloud. Typically, the banking industry is a little bit slow, but we also don't have a way out to basically stop any movement onto the cloud, and we are getting onto the cloud bandwagon. As a result of this, in fact, the traditional on-prem security, perimeter security controls are of no use for us. And as a result of this, our perimeter gets extended onto the cloud. And when you say on cloud, it is now actually not to a single cloud service provider, but multiple cloud service providers like Azure, AWS, as well as GPA, Google Cloud. Not again limiting to only these three service providers, but we now have a lot of SaaS service providers like software as a service providers to which we have to hook up to their cloud to basically get our services done. Where our perimeter now gets extended to multiple service providers or multiple cloud service providers, multiple SaaS service providers, as well as our perimeters gets extended to at homes where our laptops and mobile devices are extended. So that has been a major change in the last 4 to 5 years. Second change that I see is because the data is increasing and it's increasing exponentially. Traditional security mechanisms like SIEMs are not sufficient enough to basically really quantify our cybersecurity threats and mitigate those threats. As a result of this, with the significant exponential increase of the data, we don't have a choice than to really start using AI and ML for mitigating the threats or do predictive analysis for security mitigation. We are not stopping there anymore. Now that we have the quantum computing coming in, we have to start think forward-looking as to see as to what the threats that quantum computing for us in the next era, and what are the threat landscape, how the threat landscape is changing with quantum computing. So the topic that we are going to talk about is this. Now, before we get into details of cybersecurity in the age of AI and quantum, let me just give a little brief about the domains that we will be covering. We'll be covering the network security in the era of AI and quantum. We'll talk about cloud, how the cloud security landscape is changing, how the endpoint security is changing, What are the changes in the application security? One of the key changes that we normally talk in this case is something like identity and access management. How data security is changing in this era of AI and ML and quantum. And we'll also talk about other domains like how vulnerability management is changing, how patch management, how patch security management is changing, how DevSecOps and threat hunting is changing. We also are spending a lot of time on governance, risk, and compliance, how that landscape is changing, and eventually how governance and audits are changing when the regulators are basically auditing us. And at the last, I'll be basically talking about the next generation cybersecurity, how to basically develop the AI and quantum resilience. I'll also talk on the last slide, which talks about basically how the whole future roadmap for the organizations are coming in the quantum age. So that's what I'm going to cover. I don't have too many slides to cover. I'll try to be as specific as possible. I may not be, I'll be running a little fast. I have around 36 to 40 slides to cover. Okay, so be with me. First of all, what are the changes in the quantum computing? Now, quantum computing, if you really look at it, is a field that really uses quantum mechanics to perform all the calculations much faster than the classical computers. If you look at it, it works. Normal classical computers are actually using bits and bytes. We typically use 0 and 1, but quantum computing uses qubits. Now, qubits, which can be a superimposition of both 0 and 1, and can be really entangled with each other. Now, this allows quantum computers to really process complex information and really solve complex algorithms and problems like cryptography, especially cryptography and drug discovery, which are really currently impossible for classical machines to really crack. Now, the traditional encryption algorithms that you see, which is DES, triple DES, AES, the classical computers that we have today are not able to crack that particular algorithms because it takes years together to really crack that particular algorithm. But using quantum computing, cracking these particular cryptographic algorithms can be a matter of not more than a day or two. And that's where the challenge really starts. Especially in cybersecurity, breaking the current encryption standards has become much easier for us in the quantum computing era. Now, this has led to the development of quantum resistant cryptography. What it involves is basically the development of post-quantum cryptography, which is called as PQC, and you'll see this particular technology coming up very often into the presentation now. Now, we use PQC to create quantum resistant algorithms and the applications of the quantum mechanics for enhancing the security through methods like quantum key distribution. Now, these are the methodologies, keys, encryption algorithms which are now evolving in the quantum era. The whole idea is to basically safeguard the data, communications, and the systems which are against both current and vulnerabilities and future quantum enabled attacks. So that's what our objective is going to be like. How do we really safeguard our data, our communications and systems while using this quantum computing? I'll move to these slides now. Now, if you look at it,
sir, sorry to interrupt you.
Where do we need to really go?
Sir, sorry to interrupt you.
Yes.
Some participants are not able to hear your voice clearly.
Okay.
They are saying that the voice is breaking.
Now?
Participants, can you please put in a response in the chat box whether you are able to hear clearly or not? Sir, also, can you make the slides as full screen?
Yes, hold on.
Yes. Thank you, sir. Thank you. Yes. Now the voice is clear, sir. We have got the response in the chat box now.
Yeah.
Thank you, sir. Sorry for the interruption.
Okay. Not an issue. Okay, we are on slide number 2, where we're talking about why traditional security is failing. If you really understand where we need to go, we must really acknowledge why our current defenses are really failing. Our models are largely reactive based, but the perimeter has really vanished. With the cloud, with the remote work, with the IoTs coming up, the attack surface is now completely everywhere. Traditional signature-based detection of antivirus and IDS is now completely useless. We do have these zero-day attacks or polymorphic malwares that changes its signatures with every infection now. Furthermore, there's a widespread adoption of encryption, while good for privacy, but it creates a lot of blind spot. There are threats which are now hiding in plain sight within encrypted traffic. So today with quantum computing, we can actually decipher the encrypted traffic, and our traditional monitoring tools are of really no use. So we have this quantum vulnerabilities, which are sufficiently powerful quantum computers, which may be 5 to 15 years away, will be able to break our traditional encryption algorithms using RSA and elliptic curve cryptography, which is called as ECC. Okay. We can use the Shor's algorithm and crack these particular encryption algorithms as well. Now, this is not a theory anymore. It's a mathematical certainty using quantum computing. If you must have seen, there is a lot of harvest now, decrypt later attacks, which are already happening. What it means is there are a lot of all these the encrypted algorithms are basically have saved into a location and basically later decrypted to analyze the content or data inside that particular encrypted algorithms. And that is called as harvest now, decrypt later. Now, this is where the quantum computing is making the cybersecurity vulnerable. Trying to move the slide. Give me a second. Okay, you're able to see the slide, which is future pillars of cyber defense. Now, if you see, what is the answer to this? It's not a single bullet that we will be able to address all these issues. It's a combination of basically 3 pillars. One is AI, ML, PQC, and then integration of this AI, ML, and PQC is something which will be able to really address this particular issue. So post-quantum cryptography, which is what we call as PQC, is a new suite of cryptographic algorithms designed to be secure against both classical and computer attacks. This is about rebuilding the complete foundation of the trust. So finally, integration of these technologies will not exist in silos. So you have to basically use AI, ML, and PQC together, which will really create the true power to mitigate all this particular risk coming up through quantum computing. Now, we'll actually get into the network of the first domain, which is basically network security, which is also called as a lifeline of our cyber domain. If you look at it, let's start with the network. The traditional first line of defense is really now transforming from a static guard into a dynamic intelligence system. So instead of using manual and static rules, we now have adaptive firewalls that use really continuous learning to understand normal network behavior and spot deviations. They really perform proactive blocking by correlating internal traffic patterns with global threat intelligence feeds in real time, and thus stopping the threats before they can really breach the perimeters. So if you look at it, the ML-based micro-segmentation is also a game changer now. It really creates dynamic secure zones within the network, isolating basically all the devices instantly and dramatically reducing the attack surface. So ML, in case if any devices are really being attacked, it automatically now is able to really segregate those devices and reduce the attack surface. There are also internet-based policies which are allow us to really define the high-level business rules on the fly. And this is basically built to the AI translate and enforce rules which have been implemented using AI across network infrastructure using ensuring the compliance and security automatically. Now, how does PQC is implemented in network security? So if you look at it, if the underlying trust mechanism is broken, this is where the PQC becomes critical. So in case of the entire network infrastructure like firewalls, VPNs, IDS, IPS, they all rely on the RSA and ECC kind of algorithms. For identifying the devices, they use the certificate management to establish the secure tunnels. Now with PQC, these all becomes vulnerable because the traditional RSA and ECC can be completely broken up using the quantum computing. And that is the reason, therefore, it is necessary for migrating to quantum safe VPNs now, using the algorithms like Kyber for key exchange. And that's the reason the future is really a combination of zero trust or never trust, always verify, underpinned quantum resistant cryptographic mechanisms. So eventually, this will replace the concept of traditional perimeter-based VPNs with the cryptographic-based VPNs, which are now future-proof. Now, moving to IDS and IPS and DDoS defenses. If you really go deeper dive into the network defenses, so AI supercharges our intrusion detection and prevention systems. ML drastically improves the anomaly detection, moving beyond the simple pattern matching to understand the complex attack behaviors or attack surfaces, which significantly reduces all the false positives that we get. Because if you look at it today, we get almost 98% false positives that plagues the traditional security operations center analysts. The traditional analyst is not able to understand the millions of threats which are coming up, which are really false positive. Now this capability becomes like AI basically provides you predictive analysis, and the AI predictive analysis models are able to really preemptively harden the defenses. So the AI has been very effectively used to basically do predictive analysis on the attack surfaces. Now for DDoS, AI has the ability to really analyze the traffic patterns with much high precision, and it allows to basically distinguish between what is a legitimate traffic and which is a false positive traffic. This capability, human beings will not have it to basically do it. Millions of threats which comes up every second. And that's where AI is being used for it. The next domain that we will actually get into is something like cloud security. Now, in cloud, the scale and complexity are much more immense. If you look at it, AI is really essential for creating self-depending environments. AI-based CSPM means basically cloud security posture management is really crucial. It doesn't just really find misconfigurations, but it predicts them based on the usage pattern and prevents them automatically, turning security from reactive to a proactive. What it really provides you is the risk-based prioritization. Whether it is an internal threat or an external threat, it basically keeps on prioritizing itself and keeps on doing self-learning, predictive analyzing to change the role base on the cloud configuration to really mitigate the threats on the cloud. So automated remediation is possible using AI and ML when there is a threat which has been found on the cloud perimeter. So we use automation tools like threat automation tool or threat orchestration tools like SOAR, which is SOAR, to contain and fix the threats which are coming onto the cloud. Now, there is also powerful emerging use cases in Gen AI to really translate complex compliance regulations like GDPR or HIPAA. What we really do is all the compliance requirements from GDPR and HIPAA are put into an executable policy as a code. And these templates actually are put onto our perimeter devices. And all the threats which are really coming up are actually checked with this particular policy as a code. And that's how basically we are making the compliances for cloud. Moving to the next slide, which is basically talking about how PQC is used in cloud platforms. If you look at it, we normally use the key management services on Azure, AWS, or in GCP. These currently rely on really vulnerable algorithms. Now, traditional key management services or key management systems are not really going to be able to sustain in quantum computing. And that is the reason we now have to really deploy quantum safe KMS, which now will be able to really protect the data on quantum computing. So if you encrypt the data today with current standards, it's not going to be really stored by an adversary, and it can be decrypted in future automatically by quantum computing. So PQC really prevents this harvest now and decrypt later threats. Further, if you look at it, we need really PQC for CASB as well as for SSPM. Now, what is CASB? CASB is nothing but Cloud Access Security Brokers. This is a technology which is currently being used on the cloud. Similarly, we also used SaaS security posture management to ensure that we have every TLS session and every SaaS application connection remains secure in the quantum era also. So that's the way basically using PQC, we actually secure the CASB and SSPM. Moving to the next slide, which is talking about AI and PQC securing tomorrow's enterprises, how containerization and serverless security is taken care in cloud. Now, when we talk about within cloud native environments, there are dynamic changes again. The nature of containers and serverless functions really creates a very high security blind spots. Now, AI really brings critical visibility and defenses here over here. For containers, AI can really analyze the software bill of material to predict which vulnerabilities are actually exploitable in a specific configurations or moving beyond just CVE list. Now, CVE list is basically a critical vulnerability list that has been published as a complete library by the organizations like ISC. In Kubernetes, in fact, ML baseline normal behavior for hundreds of microservices, detecting those anomalies that indicate a breach in real time. So even basically looking at our CI/CD pipelines, AI and ML is now basically able to put up a code or configurations to basically write the policy as a code to before we deploy the CI/CD pipelines. The compliances have been done on the CI/CD pipelines using AI and ML. So that's how we do our checks on containerizations and serverless security. I'll also move to the next domain, which is endpoint security or endpoint defense. Why it is critical is because this has become an attack surface now, and it is a very wide attack surface, much more than our traditional data centers or much more than our cloud, because our endpoints are exponentially higher than our traditional servers, network, or perimeters. So endpoint has become really a new perimeter. So today we are actually deploying modern EDR, or what we call as endpoint detection and response services, which is really moving off from reactive hunting to really predictive prevention. We are actually building up a lot of behavioral DNA in every device and every user profile. What AI really helps us is to establish a baseline for normal activity and can spot our subtle malicious deviations from an attack. So that's what AI is actually able to help us out, define the baselines on the endpoints. So let's take an example when an incident really happens. AI is able to automate the entire root cause analysis on the endpoint itself only. So that we'll be able to do the tracking of the attack. And it also does the anomaly of correlating all the attacks of the endpoints and then mitigating that particular threat across all the endpoints. Now just imagine whether we'll be really able to do this manually. It's almost like next to impossible. And this is where AI and ML is actually helping us out. Without AI and ML, it's just not possible to do the correlations and anomaly detection on all these distributed endpoints. So finally, what we use is really a continuous automated simulations, constant red teaming to proactively find any weaknesses that we have before the attackers can really exploit them. So that is what predictive AI is really doing on the endpoint. I'll probably go a little faster. I'll move to the application security. Now, application security, if you really look at it, has changed the complete landscape. AI is now completely entangled into an SDLC lifecycle. So something like you have the SAST tools or DAST tools, which is like static application security testing or dynamic application security testing. These are traditional tools that we used to use. However, if you look at it, these SAST tools and DAST tools are famous for basically having a lot of high false positives. And AI is now have given an advanced context analysis to basically distinguish between the vulnerable code and the code that is really exploitable. This has really saved a lot of time of the developers. So before this particular code is deployed, AI basically gives the complete context analysis. That's how we are using AI in software securing the software code and software deployment. Moving to the next one. PQC digital signatures are now absolutely essential to ensure the authenticity and integrity of every piece of code. what we deploy in the systems. Something like we are now started deploying something like web application firewalls, API gateways. All this has to be now adopted with PQC. So we traditionally have the TLS connections, like we have TLS 1.0, TLS 2.0. These are already vulnerable. I mean, we have moved from TLS 1.0 to TLS 2.0 because there has been a lot of vulnerabilities in TLS 1.0. TLS 2.0, we are able to basically mitigate all the threats, most of the threats. But with quantum computing coming in, even TLS 2.0 is not secure enough. And that's the reason, in fact, we are now introducing PQC algorithms in TLS to ensure that quantum computing is also will not be able to decipher the TLS 2.0 and the forward-looking algorithms in the TLS 2.x. So that is how we are ensuring using PQC algorithms to prevent the future attackers using quantum computing. The next topic that I would like to really cover is identity and access management. Now, this is one topic which is really managed very closely by the organizations. And why I ask this is vulnerabilities, 80% of the vulnerabilities are actually from inside the organization. It is only 20 to 30% of the threats really come from outside the organizations. And when we want to control internal threats, the very first piece that what we do is to basically control the access. Typical identity and access management is all about basically providing the least privilege access to the end users, or even to the system users, or even to the domain users. And then basically we are now moving to something like a role-based access. Now, we will always have generic IDs, we have privilege access IDs, but with large organizations, it becomes very difficult to really control them. And hence, identity and access management is normally a vertical by itself in any large organization. So do we have it something like in our bank? Now, how the whole AI and ML is really changing the landscape of identity and access management. If you look at it, AI is really transforming from a static one-time gate checks to a continuous risk-aware process to validate the accesses. Our MFA is become a de facto standards, like multi-factor authentication becomes a de facto standard. We do not rely only on a single authentication. Within MFA, in fact, there are multiple ways of authentication. We use device authentication, we use face recognitions, we have biometrics, and so on and so forth. But even these traditional MFAs are also failing. Sorry, sir,
may I disturb you?
Sure.
Sir, your voice is breaking and it's very feeble. Can you be louder, or can you check your mic, please?
Okay. Can you hear me now?
Yes, sir. Yes, sir. Far better. Thank you, sir. Sorry to disturb you.
Okay. So I'll have to basically speak in the speakers. This will be better now.
Yes, sir. Yes, sir. Thank you.
Now, so when it comes to multi-factor authentication, ML is really powered behavioral biometrics, which is basically becoming a very fascinating area now. The ML powered behavioral biometrics is one new area which is coming up. It can really silently authenticate users based on their unique patterns. I don't know whether you are aware of this, but this is one of the big threats in the industry today. Typical rhythms or mouse movements, or adding a layer of security without any user friction. AI-driven anomaly detection monitors all the SSO sessions across all the applications it really does flagging impossible travel to access to the unusual resources now. So today, what we are really looking at is just-in-time privilege elevation. We do not by default give all privilege access to all the users. We elevate the access just in time. And that is again not possible through human access. And that's why we are now using AI for just-in-time privilege access elevation. These are the methodologies that AI is actually helping us to prevent usage of privileges within the organization for exploiting the infrastructure or exploiting the complete business operations. Now, how PQC is actually helping in IAM. If you look at current MFA standards, we have like a FIDO2 or a web authentication. These are current standards that we're using. Now, these current standards are actually vulnerable using the using the current cryptographic methods. And that's the reason it becomes vulnerable using quantum computing, because quantum computing will be able to decipher all these standards now. Now, what does it mean for us? This means really the next generation of hardware security keys and physical access cards will need to be built in PQC authentication. So like we have a standard SAML authentication or OIDC tokens that facilitate single sign-on across the internet or across the data centers. These now need to be really signed with PQC algorithms to prevent the session hijacking or identity forgery. So these are the kind of PQC is now getting used for building the latest algorithms for hijacking these identity and forgeries. I'll move to from identity and access management to data security. Now, in data security, what is the end game? Our end game eventually has to be, we definitely need to protect the data. Now, traditional methods, manual methods are really not sufficient enough, and that's the reason AI makes data protection much smarter and much more contextual. You must have seen the AI-powered DLP. What does AI-powered DLP does? Bottom line, it understands the context of the data. Is this a routine data, or is this a routine business share? Or we are basically somebody is really exploiting the rule base. That is something which is now done by the AI-powered DLPs. Now, the AI-powered DLPs, we are using it on endpoints, on servers, on network devices, and those are the ones who are actually automatically detecting the DLPs. It also does predictive analysis of who can exploit the data onto the endpoint devices or onto the servers or network. That's the predictive analysis AI is using on using the DLP. So that's how we are using AI in data protections at various levels. How PQC is actually getting used in data security now. Now, traditional, as I talked about it, the RSA keys or ACC keys can be completely broken. The TLS algorithms or SSH algorithms or IPsec tunnels, the key exchanges can be completely broken using quantum computing. Now, what we are actually introducing is PQC-based encryption algorithms, which does not have a definite mathematical models. And that is how we are now putting up new encrypted tunnels, new encrypted algorithms using PQC. Now, this is about our are encryption algorithms. We also use token mechanisms for alternate authentication. Now, even the tokens are now getting PQC protected. So that is how the quantum computing is really changing the landscape. Moving to, I'm just expanding the horizon now. If you look at it, the threats have now increased in vulnerability management. Vulnerability management is a big threat for all the organizations. What happens is typically all the organizations that we are into, in fact, we end up basically using a lot of licensed products. We end up using third-party licenses, be it Microsoft, be it Oracle, be it SAP, or be it IBM. And all these organizations will have a legacy code or legacy licenses, which we keep on basically doing lifecycle management. Not necessarily that we'll be able to keep up the pace every time. And as a result of this, what happens is there are a lot of vulnerabilities that keep on coming day in, day out. In fact, in the organizations, there are two things that takes the precedence. The highest precedence is for risk and compliance and enabling the risk and compliance. So basically mitigating the risk and compliance is the highest priority that we have. And for mitigating the risk, the biggest threat really comes from the vulnerabilities that are exploited through these existing licenses or the existing softwares that we deploy in the organization. So this is always a continuous process to mitigate the vulnerabilities. Now, mitigating the vulnerabilities has gone to an extent that today we are not able to do manual mitigation of these vulnerabilities. Let me tell you, our 30 to 40% of our expenses actually are now today used for basically mitigating the threats, mitigating the vulnerabilities. And because the landscape has grown up exponentially, we are not able to do manual vulnerability management. And this is where AI is actually helping us out. Now, beyond the core domains that we have today, in fact, if you look at it, AI and PQC are the ones who is revolutionizing the practices like vulnerability management. Typically, the AI doesn't just list the CVEs. Now, CVE score is something which has been given by all the traditional vendors. What AI does is it doesn't look at the standard CVE scores. What it really uses is it uses ML-driven risk scoring to prioritize the patches that needs to be deployed based on actual exploitability and context within the specific environment. So that is an advanced mechanism that ML uses to prioritize the patches needs to be deployed onto our entire infrastructure. Now we also do automated penetration testing using AI, which is again a new field that has come up because manual penetration testing has a lot of limitations. The attack surface has changed. Penetration testing cannot be just done on a network or cannot be done only on application. It cannot be done only on the servers or it cannot be done only on the endpoint devices. It is an amalgamation of multiple functions now. And that's the reason we have started using the AI power for doing the automated penetration testing, which basically uses continuous, we use the continuous probes for defenses. And we also started using the predictive analysis, which can really forecast which vulnerabilities may be coming up and which vulnerabilities are getting developed by the attackers. So these are the feeds that we get from the external world. And we use this particular field for predictive analysis. So these are the changes that are happening and which allows us for basically do preemptive patching. We do not wait for the vendors to come back to us saying that, okay, this is the patch has to be deployed. AI is actually doing predictive analysis and telling us which patch to be deployed. So these are the changes that are really happening using AI vulnerability management, patch management. Similarly, coming back to PQC-based patch security management. So what I talked about is basically predictive patch management, right? Now, question is, if the patch is not coming from the vendor or the OEM, how do we really trust the patch which has been given by AI is something which is really deployable? Now, if a vendor really signs their updates with a vulnerable RSA algorithm, attacker can really forge the malicious patch using quantum computing. And that's where the PQC signatures are coming into picture now. We are using PQC signatures for all the software patch updates. And that is where the landscape of patching is actually changing in the quantum computing era. Okay. So this is how our vulnerability and patch management processes are getting changed using PQC algorithms. I'll move to the next one, which is AI in SecOps and threat hunting. Now, in the Security Operations Center, we have started this traditional SIEM-based threat hunting is not sufficient anymore. Because if you look at it, the analyst who was sitting on the SOC is getting millions of incidents and events. Most of them are going to be false positive. The SIM is able to do the correlation also, but even after that, he still gets thousands of events onto his dashboard. Manual efforts are really not sufficient to really analyze those incidents and events which are coming to his dashboard. And that is where AI is being used to basically do the automated correlation of the events and really highlighting only the ones which has high fidelity, high risk incidents. So we are using the SOAR automation, which really allows the system to really execute the entire response playbooks autonomously. Okay. So that is how we are using predictive AI analytics to basically identify the alerts and identify the critical alerts or high risk incidents. And then, of course, mitigation is also animalized because we can use predictive analysis to understand what kind of threats are coming and what kind of mitigation is really required. Nowadays, we are not having any intervention unless and until there's a critical zero event which is actually happening. Again, that is also not manually intervented. That is also we normally keep on looking at it unless and until there's a manual intervention required. AI takes care of mitigating those threats. So that is a change, a lot of change in transition from basically manual mitigation to AI-based mitigation and AI-based predictive mitigation. I'll move to the next area, which is PQC, how PQC is really used in SecOps. So if you look at it for long term, especially in the quantum computing era, all the forensic logs and telemetry must be now PQC signed. This is to basically ensure that the integrity for future investigations and to maintain a legally admissible chain of custody. What I'm saying here is, in fact, whatever evidences that we put in front of the regulators, so this has to be tamper proof. And PQC actually helps us on that to basically ensure that whatever evidences that we are creating also has to be completely tamper proof, which has to be put up in front of the regulators or auditors. So actually PQC ensures us for creating these digital evidences, and manually it is just not possible anymore. I'll move to the next area, which is governance, risk, and compliance. Now, even the governance, risk, and compliance area is completely transformed. If you look at it, AI has automated continuous compliance monitoring. What means by compliance monitoring? We have a standard GDPR and HIPAA framework, and we are annually audited for against all the compliances against GDPR and HIPAA every year. Many a times it actually happens twice a year or thrice a year also. And it's actually a very painful area of audit. This is one area which we always avoid. But we can't avoid because regulators are very always keen to come on time and basically audit us in detail. And what we really are feared of is basically regulators coming and basically creating observations onto our controls. And that's where, in fact, we are now started using a lot of third-party vendor risk from public disclosures, data breaches. So we are using GenAI as a very powerful tool for policy creation. We use the GDPR and HIPAA templates, their controls. We use GenAI to basically create the baseline using these particular controls. And we start basically implementing them on the existing infrastructure. So what it actually helps us for us is to basically give a clear, comprehensive security policies in normal, natural language. And the templates basically put all the controls automatically using GenAI. So that is how the life has been simplified by us, for us using GenAI for GRC and compliance. Other areas that we are talking about, and I'll also cover something like how do we use PQC in governance and audit. So nowadays, in fact, for quantum computing algorithms, we are using PQC signed audit logs and policy documents, which are now crucial to prevent the falsifications of compliance evidence. Because the compliance evidences can be again falsified, we are using PQC signed audit logs now. So PQC ensures that the sensitive information is really shared securely. It is maintained securely, and there is a trust across entire ecosystem. That is where we are using the quantum computing algorithms. Lastly, next we go to the next generation cybersecurity and AI quantum resilience. Now, if you look at it, where does all this add up to? There's a vision for autonomous cyber defense ecosystem. Imagine a digital infrastructure that can completely defend itself, be it network or server or a perimeter or a distributed endpoint devices that are really self-healing, that deploys the mitigation threats, the threat mitigation codes automatically. And there's a global collaborative AI defense network where the threat intelligence is shared and analyzed at a scale impossible for the human being. Because let's take an imagination. I have an organization of around 45,000 people. I have 50,000 endpoints, like laptops, desktops, and mobile devices. I have another 15,000 VDIs. I have 40,000 servers. I have 20,000 network devices. I have 20,000 applications. And if you try to do a defense ecosystem using manual methods, in today's era, it is completely failing. What I now read is basically AI-powered, completely self-healing system to identify the threats, to detect the malwares, to automatically detect the threats. And I don't have time to manually mitigate these particular threats, which are coming almost like millions in every second. And that's the reason I don't have a choice than to establish a very collaborative AI defense. And that's what we are currently using it. What is actually moving in the quantum computing era in terms of cryptographic is something which is what I'll cover the next. Now, this is an era which is basically where it is evolving. We are actually now building a quantum resistant cryptographic infrastructure. This is again in a build stage, not completely implemented. And what it really requires is a proactive industry-wide migration to PQC. This is not adopted by the complete industry as of now. Very, very few organizations are really adopting PQC algorithms. And there's definitely a pragmatic approach to start with a hybrid cryptography. Because typically, if you see the evolution of DES, triple DES, AES, we've been using for I think more than 2 or 3 decades now. And suddenly moving to PQC-based algorithms is going to take a long time. And my apprehension is it may take anything between 5 to 15 years to adopt PQC-based algorithms. So this is to basically ensuring security of today while future-proofing for tomorrow. The idea is to basically, we must prioritize PQC in the foundation layers of VPNs, TLS, single sign-on, digital signatures, encryptions using basically adopting the PQC algorithms for encryptions. This is what we'll have to really adopt. But however, it is going to take a little longer time. Just imagine, in fact, I remember moving from DES to triple DES has almost taken little less than a decade. And from DES to AES, it was at least another 5 years. But from moving from these kind of an encryption algorithms to something like PQC-based algorithms,
Hello. Hello, Rajesh sir.
I think there is a network issue at Dr. Rajesh's place, I think.
Yes, we'll ask him to reconnect. Participant B over here.
Yes, ma'am.
Hello, am I audible?
Yes, madam.
Yes, participants, it seems like bit network issue with the speaker. So if he gets connected, we'll continue the session. Till that time, I would like to share the details regarding our tomorrow's session. Everyone, please note tomorrow's session will start from 2 p.m. IST. I repeat, tomorrow's session will start from 2 p.m. IST. There is the regular sessions we were having, that is 6 to 9. The last day session, as per it is also mentioned in the schedule also. The last days we are having 3 sessions over there. First session will be from 2 to 3:30. Second session of last day, that is from 3:30 to 5. And the third session will be, that is 5 to 6:30. And the most important thing you should notice, everyone, please don't miss that one. That is 6:30 to 7:30. It will be the online quiz. Okay, I repeat, from 6:30 to 7:30, it will be the online quiz that will be for only 30 minutes. It will start from 6:30. So that will be only for the 30 minutes. 25 questions will be there to attempt, and this quiz will not be shared by us, but the participants has to log in to their own with their own login credentials on ATAL portal. I repeat, participants has to register on the ATAL portal by their login credentials, and on ATAL portal you have to submit your you have to attend the quiz over there. You have to submit the quiz over there. And one more thing, between this 6:30 to 7:30, you all are supposed to do, that is the feedback. Tomorrow we will be sharing the feedback link the way we are sharing right now. That is for the individual session. But the last day, that is between 6:30 to 7:30, the overall feedback will be taken, and that is also not from our end, that will not be from the college end, but that also you have to submit on ATAL portal by log in over there with your login credentials. So tomorrow's session will be from 2 to 6:30. 3 sessions will be there. And after that, 6:30 to 7:30, it is compulsory to attend that feedback, to submit your feedback and to submit your test over there. It will be the online test. It will be the MCQ test. So that you are supposed to attend it on your ATAL, on the ATAL portal by your login credentials. So please don't miss it. These 2 things, if you are submitting, then and then you will be eligible to get the certificate. That certificate will be available again from the ATAL portal only. I repeat, that certificates will be available from the ATAL portal only. Okay. So please be careful. And after that, we are having the valedictory function, that is from 6:30 to 8. It will start sharp 6:30. The valedictory will start sharp from 6:30 and it will be till 8. So if any doubt you have, so you can raise your hand. We can answer regarding your feedback and the test that is for tomorrow. The previous whatever feedback you have submitted, the sessions you have attended. So based on that, your attendance will be marked over there. So we will mark your attendance and you will be able to get the certificate that is on Monday morning. So on Monday morning, we will mark your attendance and you will be able to get your certificate on that day. So, but tomorrow's quiz, it is compulsory to attend because we cannot do if you are missing that quiz or if you are missing to submit the feedback form over there on portal. So if anybody has any question, they can raise over here. We can unmute you regarding the final quiz submission and the final feedback submission.
Shruti madam, sorry, I don't know why I missed, but I think I thought I got disconnected.
Yes, sir. Yes, sir. We thought that you have been disconnected, so that's why just some instructions were there, so that I conveyed to the participants. Over to you. You can continue. Thank you, sir.
I don't know on which slide I lost you people.
1 second. 1 second.
Because at the back end, I was completing the entire.
Yes, yes. I thought so that you might have missed. 1 second. Sir. Divya madam, can you just. Divya madam, are you there?
Yes, ma'am. Yes, ma'am.
If you
The last.
which was this slide, if you can read in your presentation.
Okay. Give me a second.
Just a minute. Just a minute. I'll let you know.
Are you able to see the slides?
The previous one, sir. 3-4 slides. Still.
Yes, sir. We did this slide. We completed that slide. Yeah. This one also. Yes. We have to start from here.
Okay. This is slide number. Okay.
Yes, we have to start from here.
Got it. So what I was talking about, can you hear me?
Yes, sir.
Yes, sir. We can hear you. Yes, sir.
Okay. Now, what I was talking about is basically next gen of cybersecurity. Now, what we all talked about, where does it add up to? Now, we are creating a vision for autonomous cyber defense ecosystem. Now, just imagine a digital infrastructure which can really defend itself, be it networks or self-healing deception systems that can be automatically deployed. And what we really require is a global collaborative AI defense mechanism or AI defense network, where threat intelligence is automatically shared, it is analyzed, and at a scale impossible for human beings, it can be completely automatically mitigated as well. What I mean here is, let's take an example. I have around 45,000 end users, 50,000 desktops and laptops, another 10,000 mobile devices, 20,000 servers, 20,000 network devices. I have another 15,000 applications, and all the threats which are coming across such kind of a huge landscape is obviously not possible for us to basically do the threat detections and mitigation simultaneously. And that is where I require an autonomous cyber defense ecosystem. And this is now really possible through a global collaborative AI defense system. That's what we are using right now. We are using AI enable to basically automatically detect the incidents and events, and not only detect, we are able to create the anomalies. We are able to even do the threat mitigation using AI enable now, because it has gone beyond the human management to really manage these particular threats which are coming through such a large landscape, and with millions of threats which are coming up every second. I'll basically talk to the next area, which is quantum resistant cryptographic infrastructure. Give me a second. Yeah. Now, this is a topic of future development. We are still not started with these kind of developments, but we have started building a quantum resistant cryptographic infrastructure. And when you say that, if you look at it, we have taken DES, triple DES, AES. From moving from DES to triple DES, if I recollect, it has taken me more than a decade. From DES to AES, it must have taken around 5 to 8 years. But from moving from these encryptions standards to something like PQC is going to be much more harder, because they're going to require a lot of capital investment to basically adopt PQC. And what it means is basically, one, you require a lot of capital investment for this. Your hardware has to basically able to support PQC algorithms. Your applications also needs to be really geared up to adopt quantum resistant cryptography. And that's the reason, if you look at it, we'll have to really enhance our foundation layers like our VPNs, our TLS infrastructure, our digital signatures. All that has to be really upgraded. More than what it talks about is basically upgrading our hardware and software. We also basically have to train our workforce to adopt this PQC infrastructure. Now, if you look at it, whether only AI or only PQC alone can deploy this or deliver this, really not. So we'll have to basically start developing this strategic synergy between AI and the PQC roles to develop and deploy the intelligent quantum resistant cryptography or PQC enabled cryptographic infrastructure, which will be quantum.
Hello. Sir, am I
Rajesh, sir?
audible? Okay, it seems like he's facing some network issue. Yes, someone has raised prior. So can you raise your hand so we can resolve your query?
Sorry, I think was my mic mute?
No, sir, actually it got froze.
Okay. Now, what I'll do is I'll probably stop and basically take any questions that
yes,
you
sir,
have,
sure,
because
sir.
I know that we are left with 4 minutes.
Yes, sir, sure.
Participants,
yes.
you are having no questions? Any questions from the participants? You can raise your hand, so we will unmute you, or you can write it in the chat box also. No questions.
Yes.
Okay, so we don't have any questions. So Shweti ma'am, can we proceed to close the session?
Yes, ma'am. You just will just say thanks to sir,
yeah.
and
there is one question.
There is one question.
How to deal with zero-day attacks?
Exactly. And this is a big problem for us. Today, if you look at it, it was a problem yesterday, not anymore. Why I say that is, if you look at it, zero-day attacks are not predictable by the human beings. What we typically do is, we do get these particular feeds from various third parties. And we use AI/ML for predictively detecting these zero-day attacks. So let's take an example. In fact, there is a zero-day attack in Australia, and we have systems based out of US. What we have in intelligence systems is basically using AI and ML based. We keep monitoring, or we keep getting feeds all across the globe. If a threat is actually, there is a zero-day attack in Australia, but by the time it comes to US, we're able to predict it using AI and ML. And we start mitigating it before even it hits us into our US geographies or UK or Europe geographies. So that is how we are basically able to mitigate the zero-day threats from the zero-day attacks. But today's AI and ML mechanisms are able to do a predictive analysis for these zero-day attacks. That is how we are dealing with it.
So another question is how AI can be helpful in the context-aware adaptive authentication mechanism.
Yeah, in fact, there was, I think, almost 3 or 4 slides that I had talking about identity and access management and multi-factor authentication and how predictive AI analysis can actually, there is a real-time enhancement for increasing the access in the real time. So what we have is role-based accesses that has been a traditional mechanism. Today, we are now actually adopting technologies like not giving the list privileges to any privilege access also. And in the real time, enhancing that particular access using AI and predictive AI. So that's how AI and predictive AI is actually helping us out in giving just-in-time access. And when the role is over, AI is also able to predict it, that the role is over. It basically brings down the complete access level for that particular user profile or for the ID. Okay. That's how we are using AI and ML for predictive access control.
We have another question by Dr. Neeta Raskar. Dr. Neeta, you can unmute yourself.
Yes, I am audible.
Yes, ma'am.
Okay. My question is that which is the biggest challenge in defending with zero-day attacks? Which is the biggest challenge is defending against zero-day attacks?
See, zero-day attacks, the biggest challenge that we have is, let's take an example. If we are not able to predict the zero-day attack while it hits us. The issue is basically how to create the mitigation strategy within a short period of time. I'll give you an example. I have a Azure VPN or a Pulse Secure VPN or a Zscaler VPN. I have a zero-day attack on my VPN gateways, and the real challenge is to basically mitigate it before even it hits into our critical systems. So the biggest challenge is to first of all,
Okay, sir.
Apply that mitigation strategy within a short. That is my biggest challenge.
Thank you, sir.
Thank you, sir.
So we now move to close the proceedings of the day. On behalf of all the participants and the organizers, I sincerely thank Mr. Rajesh Kode for delivering such an insightful session on cybersecurity and AI integration. His valuable perspectives on securing digital ecosystems while harnessing the power of AI have truly deepened our understanding of the opportunities and challenges in this critical domain. The practical insights and real-world experiences he shared will definitely guide us in exploring innovative approaches to technology and security. We are grateful for the time and the effort you have dedicated to enriching today's faculty development program session. I also extend my thanks to all the participants for their active involvement and enthusiasm. Let us once again express our heartfelt gratitude to Mr. Rajesh Kode for this inspiring session. Thank you so much, sir.
Thank you very much, and really appreciate your patience.
Thank you so much, sir. So participants, we end the proceedings of day 5. So we meet tomorrow at 2 p.m. for the concluding day of the faculty development program organized by Sadhu Vaswani Institute of Management Studies for Girls. Thank you so much. Good night.
One minute, ma'am.
Yes,
there were some questions regarding tomorrow's feedback and all. So any one of you are having, so you can raise your hand.
I think in the chat they have written that there is a confusion regarding the test and the feedback. The test and the feedback both will happen on the ATAL portal, both of them. So you have to log into your account on the ATAL portal between 6:30 to 7:30 and complete both the things. Apart from that, the feedback link which is shared on the chat, that also has to be done by all the participants.
Santosh sir, yes, you can. You can unmute yourself. Team, can you please unmute Santosh sir? Yes, sir.
May I audible, ma'am?
Yes, sir.
Ma'am, same program I'm attending, and the ATAL server is not properly working because more than 200 people are logging that time.
Sure, sir.
So lot of problems are faced that time because the server is not properly working and answer is not save and proceed.
Yes, sir.
So the lot of problem that time because the link and time not sufficient. So I'm request to you, ma'am, please coordinate that things.
Yes, sir. Right now it seems that it will work properly, but if you are if we are facing some such type of situation, so we will resolve it on that time. No worries, sir. But the quiz and feedback is compulsory, and someone has asked which login credentials. So ATAL portal, on ATAL portal, you have done login already, and by that login you have applied for this FDP. So using that login credentials, participant, you can attempt that online quiz as well as feedback. Any other questions, please? Sure, sir. Thank you. But please don't miss the feedback of tomorrow, that is on ATAL portal, and don't miss the quiz. Otherwise, this too will be the compulsory thing to be done to get the certificate. Anyone else?
There is a comment in the chat box. So tomorrow we are having 3 sessions from 2 o'clock onwards, 3 sessions, and then 6:30 to 7:30 the test and the feedback, and after that the valedictory program would be there.
Yes, and someone has asked, do we have to log in for valedictory? Yes, the same link, you will be continuing the valedictory. We will not close the meeting over there. So you have to attend the valedictory even. Anyone else? Yes, we will share all the details regarding session and schedule on WhatsApp group too. Sure.
So we end the proceedings of the day 5. So see you tomorrow at 2 p.m. for the concluding day of the faculty development program organized by Sadhu Vaswani Institute of Management Studies for Girls. Good night, everyone.
Okay, thank you. Good night. Team, we can end the meeting now.